morning or good afternoon, everyone, depending on where you're joining us from. My name is Betty. I'm here at solo.io. And today we're excited to have another session digging into various use cases possible with Gloo, our next generation API gateway. So today we have Rick Ducat, Director of Engineering. He's going to talk about some advanced use cases for rate limiting using the Envoy API. This session is being recorded, so we'll send out the recording after the talk and also the slides. So, and that can be shared with your colleagues. And we will also have, and if you have questions, please go ahead and type them into the Q&A window. We'll answer them at the end after Rick's done with the demos and such. With that, Rick, it's all yours.
Thanks, Betty. And thank you all for tuning in. I'm excited to talk today about rate limiting with Gloo. So we're going to start with some background, though pretty quickly in this session. We're going to kind of get straight into some demos, and I'm really going to start kind of with the basics, but quickly get into some more advanced use cases that are more representative of things that our customers and our users are experiencing. As some background, what is rate limiting? It's really the goal is to protect applications, and ultimately from we're trying to protect from failures related to bursts of network traffic, which could be intentional or unintentional. We're also trying to potentially tie our APIs that we're exposing with our application, and generally just encourage kind of usage patterns that fit in with the plan. So if we're selling an API, we might have a particular quota or a particular plan that we're selling alongside it. So rate limiting can both be used in terms of protecting your application, and it can be used as a way of kind of modeling your business. And a really basic example here of a rate limit is, I might want to enable 100 requests per second to a service. If you're new to Gloo, I'm just going to give a really quick background. There's a ton of content on our website and on our docs to dig in. But for the purpose of this, the key thing about Gloo is, Gloo is managing a proxy that sits at the edge of your application. That's Envoy, and in this diagram on the left-hand side. So the responsibility of Gloo is to push configuration to Envoy. And for the purpose of, that configuration can do all kinds of things in terms of managing traffic, how it's flowing from users to your services. You might use that to enable things related to observability or security. And in this case, we're going to set up some routes to an application that enable rate limiting. So the way this works with Envoy is Envoy has an endpoint, and essentially with Envoy, what we're doing is we're constructing these kind of listener configurations. So Envoy is sitting at the edge of our application, and it's listening on a particular port. And when a request comes into that port, depending on whether it matches on host name and certain criteria you've configured about your routes, Envoy will then apply a chain of filters, the last one being kind of a router to send it on to the application. And one of the filters that we can configure with Gloo is rate limiting. Now Gloo ships so the way that this filter works with Envoy is that you kind of plug in an implementation of an API that Envoy exposed, which is a gRPC API, and then you provide essentially a service that Envoy can connect to that implements that. So we're going to look at Gloo's kind of built-in, out-of-the-box enterprise rate limiting server. That's what we'll be configuring, and Envoy, when the request comes in, we'll be talking to that rate limiting server. And that's this kind of box that we've described here on the right-hand side. Now, in terms of the demos that we're going to look at, the first will be kind of configuring limits related to the clients. So saying, I want to make sure that for each unique client that's accessing my application, they have X requests per second. We'll get into some more advanced cases. Second, we're going to look at limiting based on HTTP methods in addition to client ID, and kind of this is related to a use case we hear often called load shedding. And third, we're going to look at how we can integrate rate limiting with things like the JWT filter to more securely enforce limits on in this case, headers, which are derived from claims in a JWT. We'll get into that a little bit later. For the first use case, we're going to look at rate limiting per client. Essentially, the idea is very simple and it's very intuitive. You want to provide unique limits for different users that are accessing the service. And we'll get to a pretty complex version of this where potentially, we would want multiple rate limits for the same remote address, potentially to kind of enforce a usage plan over a long interval, but also prevent kind of bursts of traffic in smaller intervals. But I'm going to start with the basics and shift into this demo. So let me first, I'm starting from really a blank slate. All that I've done is installed GlueCTL, and I've got an empty GKE cluster that I'm working with. And for the purpose of these demos, I'm just going to be using a little bit of shorthand in my command line K for kubectl and a few others. But as we can see, there's nothing installed in this cluster. The first thing I'm going to do is actually GlueCTL. Ooh. What I would recommend doing is GlueCTL upgrade. It looks like we've got an issue with being rate limited by the GitHub API, ironically, but we can come back to that. But ultimately, I've upgraded to the latest version of GlueCTL, which you could grab from the releases page, just so that we're installing 1.4. So this is a new release that came out yesterday, Enterprise Gloo 1.4.0. We're going to use that today in this demo. And the first thing I'll do is actually just install Gloo Enterprise. So this will take a second, and while this is going, let's look at what we're going to be installing. So the first thing that I want to kind of talk through is what we're going to, in terms of the actual service that we're going to deploy. We're going to deploy this very simple service called Spelunker that's really just here for helping us see what's going on. It helps show the example. And with Gloo, there's 2 bits of configuration we need to configure to set up a route through Envoy. So first, we need to define that service as a destination, and we can rely on Gloo's discovery mechanism to automatically detect that service and to create that upstream destination for us. So, we actually only need to create the route to that destination. That part's already created for us. Using the out of the box discovery mechanism in Gloo. I'm also applying now. So now I'm deploying that actual application, Spelunker. And the second piece of configuration to get this kind of exposed through Gloo is the actual route, and that's where you define a virtual service. So this is a very simple Gloo configuration that says to match on any domain, and there's just a single route with a prefix /. So really any path to any domain will match onto this virtual service. And this configuration just says forward that request to our Spelunker upstream. Now that should take effect pretty quickly. We're going to use another convenience mechanism here. So this is a GlueCTL command to get the actual URL for the service. I'll show you where that's coming from in a second. But as we can see, when we curl it, and actually I'll just turn that into a, so when we curl this endpoint on any path, we're getting forwarded, and this is kind of the response of our Spelunker service. And just to get a sense of where that IP address is coming from, I've deployed Gloo to GKE cluster, and using a load balancer service, our gateway proxy, our Envoy instance, is actually assigned an external IP by Google's load balancers, and that's the IP address that GlueCTL has figured out to be the URL of our proxy. And so when we curl that, it's essentially matching on that single route that we've configured, forwarding to our service. So now the setup's out of the way, we've got our single service, it's working well, and we can move on to kind of how we start to configure rate limiting for remote address. So let's take a look at what, actually before we get into the Gloo config, there are two things that we need to do to actually set up remote address forwarding. Something that we could note if we look at the response that we got from this curl request, our Spelunker service is conveniently printing out the request and the headers that it received. And something to note here is this request is not, there's no indication to the service that this request is actually coming from me. And actually Envoy, isn't really receiving my IP address, my public IP address at all. It's receiving the IP address. It looks like this request is coming from Google's load balancer. What we really want, obviously we don't want to rate limit based on which load balancer the request came through. We're trying to rate limit based, for me. And so what we need to do is set up the remote address and get Envoy to be forwarding the correct IP address of my address in the X forwarded for header. So there's 2 bits of configuration we need to establish to enable that. The first is we want to tell Envoy's listener that it should be using the remote address. So this is a configuration that essentially gets associated with the route that we had set up. And it just tells the connection manager to set that up. So we can patch our gateway object with that configuration. Let me find my command here. The second thing that we need to do is we need to instruct the actual Kubernetes service how to basically with a traffic policy so that it knows that that this traffic is basically coming through Envoy, and it should also honor the X forwarded for header. So we'll patch the actual Kubernetes service for Envoy with this additional configuration. And that's what works in GKE. With other cloud providers, it might require a slightly different configuration. Now this takes a little bit, or just a second, to actually propagate. This is actually adjusting kind of how our Kubernetes cluster is behaving. But we should be able to see when this takes effect that the actual, my public IP address is now preserved all the way through to when the request hits the service. And that gives me, once we see that, that'll give us confidence that Envoy has the information it needs to properly do rate limiting based on the specific client. While this is getting itself configured, I'm going to just like jump ahead a little bit and talk through just what that rate limiting configuration looks like. So we're going to start with the simpler, just like a simple version of this use case. Let's just say we want a specific rate limit per client. So we'll get into having multiple ones, but to start, let's just say for any unique user, for any unique client, we'll allow 5 requests per minute. So first, what we'll do is we'll patch our Gloo settings to set up that as a rate limit descriptor that basically establishes in our rate limit server that for this tuple, for this kind of unique client, in this case, it's a tuple of 1, but it's the unique client address. This is the limit to associate with it. Okay, as we can see, so jumping back, the service change finally took effect. Our requests are now going through, but they look a little different. What we now have going to our service is the actual X forwarded for with my public IP address, which means that we now have Envoy properly forwarding and Google properly forwarding the request as we expect, and we can rate limit on this header. Cool. So let me patch. So, we know what settings we want, so I'm going to apply that as a patch. Now, that's not sufficient. So all I've done is set up the possibility of using rate limiting, but what I haven't done is actually apply it to our particular route. So I've created, in other words, I've created the descriptors. I've made our rate limit server aware of these limits, but I haven't told Gloo that we should be kind of incrementing our counters when it matches on this particular request. So that's the other half of the config that we need to actually apply. We can look at what that looks like. So here was our original virtual service that created that route to our destination service. And now we'll just add this option to turn on rate limit. And really the important part is here, all we're doing is rate limiting based on a single kind of, we're taking a single rate limit action, which means we'll increment a single counter for the tuple that is just our remote address. So let's apply that. So now we should start to see rate limiting take effect. I think in that, that configuration, I had a limit of 5. So as we can see, I triggered it a few times. On the 6th request, we started to get a 429, and that's what we want. That indicates that Envoy is properly rate limiting. Now we can get some insight into what the rate limit server is actually doing and the current value of counters, but we'll get into that in a little bit. For now, I wanted to prove that this is actually working per kind of unique client. So to do that, I'm going to actually, what I would like to do is issue a few curl requests to this service, but from a different IP address, so from a different client. And to do that, I'm just going to actually navigate like SSH into our cluster, into one of our boxes that happens to have curl installed. So I'll be running this essentially from the node, the public IP address of the node rather than my own personal IP address. Let's continue, let's make sure this stays rate limited. We can actually do something like that. So we're slamming the server now, but what we should see, I need to, so now we can see our original, the client from my machine is being rate limited, but we're able to continue to issue requests from a different unique client. So we can see that this is working as we expect. But that wasn't really sufficient for our use case. So this is a great start, but what we really want to express are 2 different limits. In practice, maybe we've got a single plan that gives an overall quota. Let's say 100,000 requests per month, but we may want to limit our traffic in bursts so that they don't all appear on the same day or in the same hour. We'll simulate that here by just having a specific kind of rate limit per minute and then another one per second. So what we're essentially doing is we're now kind of taking 2 actions. We're setting up 2 different descriptors, 2 different quotas off of the same remote address with a per minute and a per second kind of key to differentiate them. And on the Gloo config side, on our route, we'll take both actions. So we'll increment the per minute kind of quota and per second every time that this route is hit, and then we should be able to see both kind of rate limits take effect. So first I'll patch the settings to kind of create those descriptors, and second I'll apply our actual virtual service. And to see this, we probably need to go back and issue a bunch of requests, but we can, this is a little hard to read, but if we kind of look back through the history now, what we're seeing is, some requests go through as we expect. So we get a 200, 200, but we do start to get rate limited because for each second, we're only allowed 1 request. And then, we see some work, but at a certain point, we'll hit our overall quota, our per minute quota, and then every request is getting rate limited at that point. So as we can see, we're kind of able to kind of work with both of these different limits. We can see them both take effect. And in this way, we can start to create much more kind of nuanced, complex rules that better reflect the usage plan that you might want to set up with your users when you're kind of selling your APIs. So that's about it for the first demo. I'm going to go back to just to kind of summarize that use case. What we did is, first we took a look at just how to rate limit based on unique client, and we proved that it was working. But more realistically, we learned how to create several different limits per user to kind of create a usage plan that better reflects both long-term quotas and kind of short-term constraints in terms of burst traffic. So we can move on to the second demo, and this is really kind of a sister to the first. It's going to be a lot shorter, but really what we're kind of going to showcase here is that we can do the same kind of thing on any kind of other key. But in that first example, I just hard coded these names per minute and per second, but you could also have other ways of defining tuples. In this case, we could create different limits depending on the method. So maybe there's a kind of a default limit of 5 requests per user, but for GET requests, we want to actually have a lower limit of just 2 per user. This is related to a use case that we hear from customers called load shedding, where you basically have kind of different controls, different kind of fine-grained ways to provide, limits. And here we're leveraging kind of the fact that Envoy's config for rate limit is quite expressive. So we can actually, not just express multiple rules, but there's as before, we have these nesting of rules, and we actually have kind of, we're looking at kind of 2 different quotas, one on just a single tuple of the remote address and one on more of a nested, more complex rule. So let's see what this looks like kind of from the command line. So first, I'm just going to apply this, like before, as just a patch to our settings. And as we've been seeing, that's what basically triggers Gloo to tell the rate limit server, here are the quotas for these different kind of tuples of descriptors. And then we can connect that to our actual route by adding the rate limit options and creating these actions on our route. Now, in this case, the actions look a bit different. So before we had 2 actions that both had a generic key on the top. One said per minute, one said per second, but now they look a little bit different because we're incrementing essentially a counter just for the remote address. That's our 5 requests per second limit, and also incrementing a counter for a specific method in addition to that remote address. And in this way, we should be able to kind of see a lower limit for specific method of GET, where we've created that 2 requests per second limit, and we can still enforce the larger limit of 5 per second on the client. So let's see that in action. So I'm going to patch again. And throughout these examples, I'm using this command to apply the patch. Basically, we keep editing the same section of a single resource. So I'm just applying it as a merge patch to highlight the patch itself. But we had the actual kind of complete virtual service, so I can just apply this. So now what we should see, our default HTTP method when we issue these curl requests is GET. So we should see our rate limit on GETs, come through after 2, just as we expect, just as we had configured. But we should see, if we issue other methods, we see that we aren't hitting that limit. I think we had a limit of 10. So yeah, so after I issue enough requests, we do hit the limit on our default fallback limit. So what this shows is, we can really do something similar to what we did before, but we don't need to just use kind of a generic, per minute, per second kind of key to identify, which part of the plan that we're in. We can actually create more complex logic, maybe by load shedding, some traffic for GET requests that are coming in, as in this example. Cool. So at this point, I'm going to shift gears and start going into a different way of essentially taking action on rate limiting. So up until now, we've been using on in our Gloo config, we've been using essentially this remote address as a way to kind trigger a rate limit. And we've been using some other things like the generic key or the method of the request. But we actually have a pretty extensive ability to rate limit on any header that is coming in. So what I'm going to do for the remainder of this demo is essentially introduce a scenario with a few different limits based on 2 headers. And then we'll start to kind of see how we can make that more secure by, rather than just relying on the client to set the header, we can kind of extract it from a JWT and we can layer on other forms of security. So the first thing I want to do is talk through what our new rules are. So basically, we're going to throw out all of the config we had before around remote address per minute, around those usage plans. Now we're going to have 2 criteria to rate limit on. The first, and they're both going to be headers, though from the point of view of Gloo settings, it doesn't really matter where they come from, but we'll see how we populate them in a second. But really, we're going to have 2 different kind of keys. One is the type of message, and the other is the number of the message. And so this is kind of it's kind of simulating a telecom style use case. And different possible types include things like Messenger and WhatsApp. And so what these rules are basically expressing are, it's using a few different features of Gloo called nesting and rule priority, but essentially what we're expressing is for any request that comes in of type Messenger, it always gets rate limited at 2 per minute. For anything that comes in with type WhatsApp, by default, we'll rate limit at 1 per minute. But if it is to the number 411 for WhatsApp, we'll give it a much larger limit of 30 requests per minute. And we're using a weight here to kind of inform Gloo of how to order and prioritize these rules. Basically, what it's saying is, if this rule gets hit, this more specific one for the number, then we won't increment this counter. So we won't we won't be rate limited on this. So we'll allow WhatsApp messages to 411 go through even after we've hit our kind of fallback limit. On the Gloo config side, so for our route, we're going to basically trigger off of 2 different headers. So if only the X type header is present, we'll increment that. And sorry, let me say that slightly differently. We'll always increment 1 counter just with the X type, just based off of X type for the type tuple. Essentially, that links us to that first rule and basically ensures that, if a Messenger request comes in after 2 of them, we'll rate limit because of that first rule. We'll also take an action on the type and number tuple so that we can get to that nested rule as well. So let's see these in action. First, I'll apply the patch to my settings. Oops, cool. And then I'll apply this virtual service. Okay, so now we're going to be, well, let's see this, let's make sure things are working. Okay, everything looks good. We're not getting rate limited. Now let's actually start to trigger, and actually for the purpose of making this a little easier to read, since the text is so big, I'm just going to leave it without the verbose flag. If we don't get a response, that indicates that we have been rate limited for now. We'll bring back verbose a little bit later. But let's see these specific rules being enforced. So remember, for Messenger, we had a limit of 2. As we can see on the 3rd request, we're not seeing a response. That means we're hitting our rate limit after 2 requests. Even when we're rate limited there, we still can see WhatsApp messages going through, but the limit there is really, it's just 1 request. So after the first one, we get rate limited there as well. But if we add the number 411, then we'll see the request go through. And let's just prove it, we're rate limited currently, but if we add that extra number, the request is not rate limited. So we can see all three of our kind of rules, different rules are taking effect exactly as we expect. So this is the foundation of this demo. Now I'm going to start to pick it apart and show kind of different ways that it's flawed and how we can address those flaws. The first flaw here is that if we don't specify a type that's well defined in our settings, then we won't enforce any rate limit whatsoever. So, I don't think it wasn't really intended that a different header here would have led to no rate limiting at all. We just forgot to introduce a fallback rule. So fixing that's pretty easy. We can just add one more different rate limit just on type, but with no specific value. And that kind of creates our fallback. So let's patch and add that. And as we can see, it immediately takes effect. Now any other type, unknown type, is rate limited just as we expect. Now there's some other cases like this, which I'll come back to, because we might want to utilize some security features to block other types of requests, but we'll come back to that in a little bit. The next flaw that we need to address is the fact that right now we're placing the onus on the user or the client to provide honest headers on which we can actually do the rate limiting. So for instance, if the client specified something different, or if they omitted the header, we wouldn't trigger our rules. That isn't really what we want. What we really want is something where we know that some authoritative source kind of gave us the values of the type and of the number. So what we can actually do is we can move that. We can basically leave rate limiting as is, but what we want is incoming requests to have a valid JWT, a valid JWT, which is a token that indicates that we've authorized them to access our service. So we want that JWT verification, and then we want to extract from the JWT, if it's valid, different claims and put them into these two headers. So rather than have the client supply the two headers, they'll supply a valid JWT, and from that JWT we'll extract the type and number because they came actually from whoever provided that JWT, which is a known authority. So let's see what we need to do to actually enable that. The first thing I've done is just created, for the purpose of testing, a public and private key pair. And in terms of the JWT, all we need to change about our virtual service, about our Gloo config, is we want to add that JWT configuration. So all I've done is we're doing local verification. So I'm providing the public key and the issuer, so we can kind of have Envoy validate that the JWT associated with the requests is actually valid. It's looking for that token in the X token header or in the token query param. We'll use that header to supply it. And there's one other feature that's utilized here. So to tie it to our rate limit config, we'll basically extract those two values from those two headers. Cool. So we can actually just go and apply this. We don't need to make any other configuration change to Gloo because we've already set up the rate limits that we want. We're just kind of supplying those values from a new source. So let's update our route. And what we should start to see are requests coming back. If we look closer, we're actually getting a 401 unauthorized response now, which is exactly what we expect because we're not supplying a valid JWT, and that is what's required based on our route configuration. I've gone ahead and created a few for us, just kind of emulating the scenarios that we looked at just when we supplied the headers directly. So first, I've got a JWT, and I'll show you one of them just to kind of prove it. There's a useful tool called on JWT.io to actually construct these or to decode them. So as we can see, the payload of this contains our issuer, and it contains a type of messenger, and Gloo can validate that this thing is actually valid. And now we can see this request is going through as we expect. And after 2, it's getting rate limited. So this is actually behaving exactly as we expect by changing the config from just a header, by adding in the JWT configuration to extract the header. We are able to kind of work with our existing rate limit config. And just to, one other thing that's worth proving is this, helps protect against something like this, where a user is actually just supplying a fake type header. By the time this request actually gets all the way to our service, we know that that header has been actually written by our JWT filter. So it's, it doesn't matter what the user provides, as long as they provide a valid JWT, this will work as we expect. And we can kind of continue it for the other examples. So this is of the type WhatsApp, and this one, is rate limited just after 1. But if we supply something with WhatsApp and the number 411, we can see the type WhatsApp, we can see number 411, and we can see that it's not getting rate limited because we have that larger limit associated with that specific combination. Great. So last thing I want to show, and then we'll kind of open it up for, then we'll close this out and then open it up for questions. But, we layered basically one set of security features on top, which is utilizing JWT verification to require that our clients have valid JWTs, and to extract, and to rely on our identity management system to kind of indicate what we should, our plan, and then actually rate limit based on that trusted authority. But there's some other limitations or some other kind of weaknesses still. This is much more secure than what we had before, but there are some other limitations. So the first is, we might want to add in some kind of web application firewall in front to actually block malicious looking traffic. The second is we might want to also incorporate some kind of authorization. For instance, we might want to inspect the payload of the JWT, and if there's no type at all, or if the type isn't one of the ones that we've written a rate limit quota for, maybe we want to reject it as an unauthorized request instead. So these kinds of things are really easy to kind of layer on top, just to kind of get you, security from every different angle. So let me just apply that real quick. And now we can kind of start to see some interesting things. So this is the request before. It was, valid WhatsApp request. But if if this looks like it's malicious according to our WAF configuration, oh, that didn't. Looks like our updated config didn't take hold yet. Oh, because I forgot to apply the other resources. Okay, so now we can see if, now that this triggers a rule that we had put in front for our WAF. So we actually can get an intervention even before rate limiting. We can also layer rate limit on top of other features like OPA or like external auth. And in that way, we can do things like block requests as unauthorized if they're for a type that we don't approve. So going back to our SMS example, if we wanted to, we could have a valid token that came from our authoritative source, but if it still may not be valid for this route based on our auth config. And in that case, we can kind of see a forbidden in the way that we expect. So this is just to show, there's a lot of different angles that you would want to think about in addition to rate limiting when you are using rate limiting as a way to secure and expose your API. Gloo makes it really easy to start to layer those on top of each other. So, we looked at how we could just do that through extracting headers. We made that significantly better by incorporating the JWT filter and extracting it from JWT claims. But we can even do better and layer additional security features on top. Great. So just to kind of wrap this up, this is a slide that highlights really the range of features. What we looked at today was an enterprise feature, which is our built-in integration with Envoy for rate limit, utilizing our rate limit server that we provide with enterprise Gloo. Now, open source Gloo, you could still use rate limiting and auth and all of these other features with open source Gloo. We just have a lot kind of that comes out of the box with our implementation. And just want to highlight, we've got a bunch of customers using Gloo. There's some really interesting case studies on our website, so I encourage you to check that out. And in particular, I drew several of the examples that we went through today were kind of from working with customers on this list. So I really wanted to highlight some representative rate limit examples, examples of utilizing these features in production settings. And thank you for listening. So with that, I'll turn it back over to Betty for some questions.
Yeah, thanks, Rick. And folks, here's some links here for you to get more information on Gloo, for Gloo open source, as well as the enterprise trial. First question here, we actually got it a couple different times, Rick, is the demos you showed today, is the code and the instructions for that available anywhere?
Yep, it's all available. I need to, I think, commit. So it's in a repo that I've been kind of maintaining called Gloo Reference Architecture. It's got a bunch of different scenarios. Betty, do you have a list of, is there a way that we can follow up with a link to it? I need to basically commit and push out these resources.
Yes, actually, that's great. Once you kind of commit those, what we can do is we send out a follow-up email to everyone who's registered for the session. We'll include the links to demos there.
I'll do this after when I can focus. Cool.
Maybe, yeah. Rick will live commit as I read the next question.
But I would recommend for folks listening and who want to try it out, as in prepping for this, I did write instructions in terms of how you can go through it. All the resources that I used, including the kind of backend Splunker service, are all here. So, it should be pretty easy to run through yourself. Great.
And then one thing is because we have Envoy at the edge, the next question is if the user actually has multiple instances of the proxy serving as a gateway, do the rate limits apply per Envoy, per proxy, or the entire cluster of Envoy proxies?
Yeah, great question. So generally we've designed the components to be completely separable and kind of independently scalable. So the application of rate limit settings doesn't really depend on how many replicas of Envoy you have. Instead, it depends on where you've bound rate limit config onto your routes, and where those on which envoys and on which listeners do those routes exist. So just to make that a little more clear, in our virtual service here, we had a single virtual service. It was bound to our standard HTTP port, and then any request going into the HTTP port would kind of trigger those limits. If we had multiple replicas of that listener, both of those would be kind of triggering the same limit, the same quota. Envoy would be talking to the same rate limit backend. So we can scale up Envoy. We can kind of granularly associate different rate limits on different routes without worrying about replicas and how we're scaling Envoy.
Great. You showed 3 different examples, rate limiting examples. When users kind of implement these, do they pick only one in order to implement, or is there a scenario where they might chain some of these rate limiting policies together?
Yeah, it really depends on how you want to design and expose your APIs. So all of the things that I showed are relatively interchangeable. Envoy offers the 2 building blocks that Envoy offers are descriptors, which define essentially for a particular tuple of values what the limit is, and then actions, which say how to construct those tuples. So in that way, you could create as many of those as you want. You could create them with different shapes depending on how you want to construct it. The way that I kind of like to work with people to refine it is really starting with that use case. So if we could describe in kind of just like English how we would want to enforce, like what policies are we trying to enforce, and then we can use those underlying building blocks that Envoy gives us to construct the policy that makes sense. But everything that we looked at here is interchangeable, relatively easy to swap in and out depending on the use case.
And then, earlier on in the presentation, you showed kind of the different kind of filters that you can have in Envoy, with rate limiting being one of them. Any comment on like what's the impact to performance on having all these filters, and how often is Envoy talking to Gloo to get the quotas or configurations?
Great question. So there's a couple things there that I'd like to kind of pull out and respond to. So the first is, in what way does Envoy and Gloo talk to each other? Gloo is basically pushing configuration to Envoy behind the scenes, not on the request path, over a protocol that Envoy publishes called XDS. So Envoy is always serving a last known good configuration, and relatively quickly when Gloo sees an update, it'll push something new, but that doesn't impact actual kind of request performance. What does impact it, as I think the question pointed out, is which filters you have in your filter chain. And that depends on, you could have a ton of different routes and a ton of different filter chains, or in our example, we just had one. In terms of the performance, it really does vary a lot. So, filter chains could do things like rate limit or auth, where they reach out to a service to make a decision and to receive a response. They could do things like WAF or JWT verification, where they do these like very rapid in-memory kind of in Envoy checks. Or they could do other things that might be a little more intensive in terms of IO, like transformations. So it ultimately does depend on which features are being used. A transformation on the body of large requests and responses is obviously going to be slower and will require more Envoy to get those requests through. But in terms of performance, like it ultimately depends on that stuff. And fortunately, rate limit can be configured to be, you can kind of granularly decide where you want rate limit to sit in that chain. So by default, it happens right after auth. We've had customers put it in front of auth for the purpose of essentially using rate limiting as a way to protect their auth server. But by happening kind of early on in the filter chain, you can kind of protect against the more costly parts of your filter chain later on.
And actually, is this something that our new latency metrics that we included in the 1.4 release, is that something that could track how this is performing?
Yeah, fantastic question. In 1.4 just came out, one of the features are these latency metrics that gives, we've basically built it in conjunction with a customer to get pinpoint accuracy on the exact timing kind of in and out of Envoy. And so that, we can develop basically a really good insight into the performance inside of, from kind of entering to exiting Envoy, and the breakdown of like where that time is being spent. So there's some new, I would look for those in the release notes of 1.4, and I think in the blog announcement that we did.
And I can include that in the follow-up as well. There's a question here on, is it possible to do rate limiting per endpoint, like login or checkout?
Yep. So I obviously I covered a lot. I didn't want to go, I had to omit a few things, but one thing that I like to mention is, this might not be super obvious, but if we look here, these options are configured for this specific route. We could have also configured it, for the virtual hosts. So in that way, like if you had a few different routes, maybe you have a route at the top called login, and that's, if any request to log in gets matched on that. And maybe you have a specific rate limit config or a specific config for that route. And you can really kind of decide where you want to put these on the granularity of per route.
Great. And then I want to say there was, is there a way to implement an IP kind of like allow list to skip rate limiting, or have different rate limits for IPs on that list?
Interesting question. I need to think about it. So we've had people do things with IP whitelisting and blacklisting using our web application firewall config. I would assume that we could do something similar with the remote address, though one of the things that we often see when it comes to whitelisting and blacklisting are the use of kind of these wildcard rules that affect broad ranges of addresses. And that I have never really played around with in the context of rate limiting. So that one is probably worth a follow-up. I don't have a definitive answer. I would imagine, though, that we could do, we've done tangential or adjacent use cases with a combination of rate limiting and with WAF and other features. So I imagine we could. I couldn't tell you exactly how that would work.
Okay, could be an idea for a future session.
Definitely.
And then how do we, the last question here is specific to the JWT configuration. How is key rotation managed? And the second part is, can you also specify multiple keys with different key IDs?
So in general, the example that I showed here is really basic, and I'm not even using a remote key server like source. I'm just having a local key. So in this mode, you could rotate just by updating your public key if that's what you want to be rotating. You're obviously typically, I would say, when it comes to your kind of identity provider and your authentication provider, we've seen that thing is issuing a JWT that we tend to work with tools like Keycloak and others that let you really customize the JWT that comes back to the user through the auth process, which should incorporate things like timeout or time to live, and it should be something that through managing that service, whether it's Keycloak or Google or whatever your identity provider is, should have some policy or some implementation of rotation for that kind of configuration. But on the Gloo side, we can always update this as a way to kind of change how we want to be verifying JWTs. Yeah, hopefully that answers the question.
Well, cool. That about wraps it up for the questions. Rick, can you go back to that slide that flashes the links?
Yes.
Great. So thanks everyone for joining today. We will be digging into more fun topics, specifically, detailed use cases within the API gateway with Rick. So watch out for invites for that. We'll try to do them, try to come up with fun topics monthly or so. And if there's a specific area that you are interested in, please go ahead and hop into our Slack community if you're not already there. You can see the link, slack.solo.io. And then we have a channel for Gloo and as well as Gloo Enterprise. And you can say hey, I'm really interested in this topic. Can you cover it next time? First link there is, first link there is the product page. And then go to the, go download open source or request a trial for Enterprise. What were you gonna say, Rick?
Oh, and just to add to that, if you're interested in running through this and you're having trouble or you want to just ask me a question, I'm on the Slack too, so don't hesitate to just drop me a DM if there is something you want to follow up about the specific webinar content.
Awesome. Thanks again, Rick. Thanks everyone for joining, and we will see you next time. Bye.
Thank you.